Today I would like to discuss about secondary metabolites. So after going through this topic, you will understand the following aspects. What are primary metabolites and secondary metabolites? What are their significance? What are the different types of secondary metabolites? How they are defined, classified? What are the properties and chemical tests for the identification of these secondary metabolites? So plant is a chemical factory. It synthesizes both primary and secondary metabolites. Carbohydrates, proteins, fixed oils, and fats are the primary metabolites. So as the name indicates, these primary metabolites are very important for the growth and development of the plant. These are directly involved in the physiological processes of the plant. So by the byproducts of these primary metabolites are nothing but secondary metabolites. So these secondary metabolites, as the name, they are not directly involved in the growth and development of the plant. They are not important for the physiological processes of the plant, but they play very important role as a protective agents, and they act as detoxifying agents as they are the end products of plant metabolism. So these are the following secondary metabolites: alkaloids, glycosides, phenolic compounds, volatile oils, resins and resin combinations. Let us go through about the alkaloids. So alkaloids are alkali-like substances which are present in the plant as base form or in the form of salt with organic acids. It consists of nitrogen in the ring or outside the ring system. So this nitrogen may be one or more than one number, and it is present as primary, secondary, tertiary or quaternary amine. So based on these, we can now define alkaloids as these are nitrogenous organic products of plant origin present as free base or as a salt form with organic acids containing nitrogen in the heterocyclic ring or outside the ring structure, bring about physiological responses in human beings when administered in small quantity. So what are the properties of these alkaloids? Physical properties. Alkaloids are usually colorless, crystalline and non-volatile solids. But there is exception for few alkaloids. For example, nicotine, which is an liquid, and berberine, which is an colored alkaloid. So, as I told, these alkaloids are present in base form or in the form of the salt. So, the free base form of the alkaloids are insoluble in water but soluble in most of the organic solvents. And if they are present in the salt form with organic acids, it is soluble in water and insoluble in organic solvents. So most of the alkaloids are optically active and laboratory. Generally, these alkaloids are bitter in taste and have marked physiological activity. Chemical properties. So these alkaloids are, as in the definition we have seen, these are the basic compounds, nitrogenous compounds, and this basic nature is because of the presence of the nitrogen, as it carries the lone pair of electrons. So this basic nature is enhanced if the adjacent functional groups are electron releasing. If the adjacent groups are electron withdrawing, the alkaloid turns to be neutral or acidic. They may contain one or more number of nitrogen and exist in the form of primary, secondary, tertiary or quaternary amine. So what are the general tests for the identification of these alkaloids? So these are the four tests which are generally used for the identification of alkaloids. So among these four, Dragendorf's reagent test is the common test for the identification of alkaloids. Let us see one by one. So Hager's reagent test, here it consists of the saturated solution of picric acid. When the alkaloid solution is treated with this saturated solution of picric acid, that is Hager's reagent, it gives yellow colored precipitate. And Wagner's reagent test, which consists of the solution of iodine, and potassium iodide solution. When alkaloidal solution is treated with this reagent, it gives reddish brown precipitate. Dredgen-Droff reagent test. So here the Dredgen-Droff reagent is nothing but it is the solution of potassium bismuth iodide. When the solution is treated with this reagent, it gives rise to reddish brown precipitate. And the fourth one is the Mayer's reagent test, where the solution consists of potassium mercuric iodide. When the solution of the alkaloid is treated with this Mayer's reagent, it gives cream color precipitate. So how these alkaloids are classified? There are various types of classification. One, based on the pharmacological actions, based on the precursor from which they are synthesized, and their distribution in different families, and the chemical classification based on the chemical nature. So pharmacological classification, which is based on the physiological responses, they are classified as anti-cancer, for example, vincristine, vinblastine, CNS stimulants like caffeine, analgesics, morphine, and symptomimetics, ephedrine, etc. So biosynthetic classification, which is based on the precursor involved in the biosynthesis, like ornithine. If the alkaloids are derived from ornithine, they are known as ornithine alkaloids, like that tryptophan alkaloids, tyrosine alkaloids. Taxonomical classification. So here it depends upon the distribution of alkaloids in different families, such as Apocynaceae, Solanaceae, Papaver. Chemical classification. So here chemical classification, it depends upon the chemical nature of the alkaloids, and this is an important methods of classification. And this is the classification, this chemical classification is generally used for the classification of alkaloids, which covers all types of alkaloids. So here in the chemical classification, these alkaloids are further classified as heterocyclic and non-heterocyclic alkaloids. So what are heterocyclic alkaloids? Heterocyclic alkaloids are also called as true alkaloids, which contain nitrogen in the heterocyclic ring structure, and also they are derived from amino acids, and they give positive test for the general chemical test for alkaloids. So based on the heterocyclic ring present, they are again classified as pyrrole, pyrrolidine alkaloids, for example nicotine, pyridine and piperidine, for example lobelin, quinoline, quinine alkaloid, quinoline alkaloids, for example quinine, isoquinoline, which consists of isoquinoline as a heterocycle, for example papaverine, indole alkaloid, which consists of the indole ring moiety, reserve ring, tropine alkaloid, atropine, phenanthrene, which consists of cyclopentanopenanthrene ring, example morphine, and imidazole alkaloids, for example pilocarpine. Then what about non-heterocyclic alkaloids? So non-heterocyclic alkaloid, it includes protoalkaloids and pseudoalkaloids. So what is protoalkaloid and pseudoalkaloid? So protoalkaloid, which does not contain nitrogen in the heterocyclic ring structure, is derived from the amino acid and gives positive test for the general chemical test for the alkaloids. For example, ephedrine. Pseudoalkaloid. So these pseudoalkaloids are not derived from the amino acids, but they give positive test for the standard chemical test for the alkaloids. For example, caffeine, carnosine, colchicine. So here you can see the table of the classification of alkaloid. So here it is the type of the alkaloid, the structure which is present, then the source of the alkaloid, examples of the alkaloid present in the particular drug, and the uses of that particular conscience. Phenylethylamine, which is a non-heterocyclic alkaloid. You can see here the nitrogen is present outside the ring. The common example is ephedra. Ephedrine is the chemical conscience which is present in the ephedra, which is used in the treatment of asthma. Steroidal alkaloid. So here it is an pseudoalkaloid. Curchi. It consists of carnosine and used as antacid drug. And heterocyclic alkaloid, pyridine and piperidine, which consists of pyridine, piperidine as a heterocyclic ring structure, and here the nitrogen which is present in the heterocycle. For example, lobelin, lobella, which consists of lobelin. It is an antipasmodic used in asthma. Pyrrole and pyrrolidine, present in coca and tobacco. High green is the conscience which consists of this type. It is an CNS stimulant. Isoquinoline. The heterocycle present is isoquinoline, present mainly in opium. And the conscience are papaverine. It is a narcotic analgesic. Then quinoline, quinoline heterocycle, present in common drug cinchona. Quinine and quinidine are the active conscience which is used as antimalarial drug. Indole alkaloid, present in the ergot rauwolfia. Reserpine is the main conscience which is used as hypotensive. Then purine, which consists of the nitrogen in the heterocyclic. And source are tea, coffee, coca. It is an CNS stimulant. And trophin alkaloid, trophin nucleus is present mainly in the datura, belladonna and coca. Main active conscience is atropine. It is an parasympathetic drug. Next, glycosides. So what are glycosides? So glycosides are organic compounds which upon hydrolysis with acids, alkalis or enzymes yield sugar part and non-sugar part. The sugar part is known as glycan part and non-sugar part is known as genin or aglycan part. And these two sugar and non-sugar portion are joined through the link which is known as glycosidic linkage. And this glycosidic linkage may be present in the form of alpha linkage or it may be beta linkage. So beta linkage glycosides are more common. They are distributed in various families like Leguminosae, for example Senna, Liliaceae, Alloy, Scrophulariaceae, Distalis, and belongs to Umbelliferae family, Brahmi, etc. Many are used traditional and modern medicines because of their anti-inflammatory, purgative, analgesic, cardiotonic, demulcent and other useful actions. What are the properties of these glycosides? They are generally present as crystalline or amorphous substances. As they are present along with the sugar, they show solubility in water, dilute alcohol, but insoluble in organic solvent. So if they undergo hydrolysis by giving the glycan and glycan part, the aglycan moiety is nonpolar and it is soluble in organic solvents but insoluble in water. They are easily hydrolyzed by acids, alkalis and enzymes. They are also optically active substances and normally liver-rotatory. Classification of glycosides. So here classification is based on the glycosidic linkage present, the sugar present in them and also based on the chemical nature. So depending upon the type of the glycosidic linkage, there are 4 types of glycosides: C-glycoside, O-glycoside, N-glycoside and S-glycoside. C-glycosides, here the sugar moiety is linked through the carbon moiety which is non-hydrolyzable by acids or enzymes but undergo oxidative hydrolysis. So glycan part reacts with the aglycan part consisting of CH and it will form an C-glycoside with the elimination of water. O-glycoside, the sugar moiety, the OH of the sugar moiety reacts with the OH moiety of aglycan part and form